Texan Global School. Exponential and logarithmic functions. This class will analyze exponential functions and their inverse logarithmic functions. An exponential function is one represented as y equal to b raised to the x, where b is the base greater than 0 and x the exponent. An example is analyzed to see the behavior of these types of functions. We will graph f of x equal with 2 to the x, and we will obtain the domain and range. First, let S tabulate proposing values of x from -2 to 2. Then, substitute in the function to obtain the values of the ordinate and thus the coordinates x, f of x. So, f of -2, when substituted into the function, equals 1/4, or 0.25. Using a scientific calculator or some tool is suggested to obtain the other values. Once the tabulation is complete, we proceed to graph. We can see the behavior of this exponential function, which has the set of real numbers as domain, but the range starts at 0 and open to plus infinity. In this next example, we will graph f of x equal to e raised to the power of x and find domain and range. First, tabulate by proposing values of x from -2 to 2. You can extend the domain as you like. Then, substitute in the function to obtain the values of the ordinate and thus the coordinates x, f of x. Once again, using a scientific calculator or some other tool is suggested to obtain the values. It is important to highlight in this case that f of 1, when substituted in the function, is equal to e to the first power, that is, e. Recall from the class of real numbers, that the number e is an irrational number whose value is 2.71828, etc. This is a way to verify that the substitution is correct. Once the tabulation is complete, we proceed to graph. We can see the behavior of this exponential function, which has the set of real numbers as domain, and the range starts at 0 open to infinity. Now, we can see the graphs of the two previous examples contrasted with other similar functions with a base greater than 0 and also greater than 1. We can see that between function 2 to the x and 3 to the x there is e to the x since the number e is 2.71828. Analyzing all the functions, we can see that they have similar behavior. They can be modified by including factors or terms to the function. The following example details a base b greater than 0 but less than 1. We will graph f of x for 0.5 raised to the x, and we will obtain the domain and range. We can see that 0.5 can be represented as 1/2. Then, tabulate by proposing values of x from -2 to 2. Now, substitute in the function to obtain the values of the ordinate and thus the coordinates x, f of x. So, f of -2, when substituted into the function, equals 4. Some values can be calculated directly, but others require a calculator. Once the tabulation is complete, we proceed to graph. We can see that the behavior of this exponential function is different from the previous ones with an opposite direction but with the same domain and range. This other graph compares exponential functions with base b greater than 0 and less than 1. They all have a similar behavior assuming an exponent x. Now, the logarithm base b of y is the exponent x, to which the base b must be raised to obtain the number y. This definition is used to find the value of the logarithms. So, we can see that the logarithmic function is the inverse of the exponential function and is represented as y equal to the logarithm base b of the argument x. Let's see an example. We will graph f of x equal to the logarithm base 2 of x, we will get domain and range. First, we will tabulate proposing values of x. The properties of logarithms indicate that logarithms of negative numbers do not exist in the system of real numbers. Moreover, the logarithm of 0 is not defined. So, we propose values greater than 0 for the domain. We substitute in the function to obtain the values of the ordinate and thus the coordinates x, f of x. Using a scientific calculator or some other tool is suggested to obtain the values. You can also use the logarithm definition to perform the calculation for each value. The closer a value is to 0, the larger the graph will grow. Once the tabulation is complete, proceed to graph. We can see the behavior of this logarithmic function, which has as domain all the values greater than 0 and the range the set of real numbers. In this last example, we will graph the natural logarithm of x. We substitute in the function to obtain the values of the ordinate and thus the coordinates x, f of x, using the calculator. Once the tabulation is complete, we proceed to graph. We can see the behavior of this logarithmic function growing, which has as domain all values greater than 0. The real numbers as range. Finally, various logarithmic functions are shown to compare their behavior from a base 2 to a base 5. They can be modified with factors or altering the argument. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com